All right, so I just figured out how to explain the membership problem for myself. And what I'm thinking is that maybe if I gave that explanation out, I might help others understand it too. So here's what we got. All right. I'm going to first just start by assuming that you know what the absurd function is. I'm assuming that you know what this is. You just remember it. If you can't, go back and look at the function in the lecture. Okay, so we have our observed function and we have our halt function. And in the proof, what we do is we have our absurd function, and then we feed absurd into it. Okay, what does this do? All right, so if we blow this up, what we do is we get if halt, but not just halt absurd, okay, then while true, right? So that's our loop, right? So these are our functions. I'm assuming we have this, right? And then else return nil. Okay, so what does this code do literally? What is literally happening when we run this code? Okay, I'm going to shrink this for a second, just so that we can see, right? So I'm going to move this, shrink it down, right? So it's going to run halt first because that's what's happening. That's in our first line of code, right? So it's going to run halt, and what does halt do? All right, so we're going to do that. We're going to run halt, absurd of absurd. So what is this doing? What does halt do first off? What it does is it takes an input. If we just go back up here, we take a machine, M, excuse me, and we put a string in there, right? And what it does is it checks if M will halt on that string, right? If halts, if stops, right? Return true. True. Okay. And then, so on and so forth. Okay. But what is this? What does this run? It runs absurd. If absurd halts, stops. Oops. I gotta move this. Run out of room. If stops. Oops. Didn't say you're getting high quality with this. If absurd stops, return true. True. Well, wait 1 second. What is this? What is this? Right, what is that? That's this function right here. That's that function right there. All right, so what's happening is we feed absurd into absurd. We run halt absurd into absurd. And in order to run halt of absurd, we run the original function again. Right, so we loop this infinitely, which is kind of cool, right? So this thing will loop infinitely, right? So I'm just collecting this thing. If we duplicate it, right, to run this, it just loops infinitely, right? So, and it's going to just do this over and over, which segues into a very nice point of the first case. The first case being that this will loop, right? That this loops. Okay, let me choose a different color here. Case 1, loops. Okay, so if this loops infinitely, like we just described, right, it just keeps going, it just keeps going, then it will stop. Well, if this stops, then this needs to stop too. Then all of this needs to stop. This can't recurse. You can't run this function. This needs to end. Right? This whole thing needs to stop. This thing stop. It can't loop. It can't just continue endlessly. But that's what it's doing. So it's continuing ceaselessly and stopping at the same time, which is a contradiction. Right? So if we take that, right, it's looping and it stops, right? But then we can take it as it's stopping, which is what technically would happen. Then it will loop. Then it's looping, right? So we're getting both simultaneous it stopping and it looping at the same time, which is impossible. It's a contradiction. And that's why this wouldn't work. So that's the proof. That's the expounded illustrative proof of the halting problem not being decidable. Undecidable. Decidable. Okay. The halting problem is undecidable.